Good morning, everybody. Today we are going to learn how to calculate oxidation number. You know that oxidation means the loss of electron and reduction means the gain of electron. Here we are going to learn how to calculate oxidation number. To calculate oxidation number, we have to know some rules, right? In this video, I will discuss all the rules related to calculating oxidation number. So be happy that you are going to learn that. Rule 1. In free state, right? The oxidation state of an element is 0. That is, you know that in P4 there is no other element without phosphorus, right? So in this case, the oxidation state of phosphorus or oxidation number of phosphorus is 0. Uh, in chlorine, the oxidation state of chlorine is 0. Here I have to say 1 chlorine, right? Well, here the oxidation state of oxygen is 0. Here the oxidation state of sulfur is 0, and here the oxidation state of oxygen is 0. I can express the language of this equation like this. The oxidation number of an atom is 0 in a neutral substance that contains atom of only one element. Atom of only one element, right? So here is the explanation of this. I think you have understood it well. Now we are going to learn the second rule, right? Well, you know that in aluminium, that is monoatomic ion, right? Positive ion. The oxidation state of aluminium is +3. Here the oxidation state of chlorine is -1, and here the oxidation state of sodium is +1, right? So what will be the rule? In case of monoatomic ions, the oxidation state will be equal to their charge, right? Here equal to their charge. Here the oxidation state of aluminium is +3, right? Well, now we are going to learn the third rule, right? What will be the third rule? Well, this is a neutral molecule, right? In case of neutral molecule, well, the summation of the oxidation state of all the elements of that compound will be equal to 0, right? The oxidation state of potassium, manganese, and oxide here. So if you the algebraic summation, right? +1 here, +7, and -8, right? Will be 0. And when this is very helpful when you are going to calculate the oxidation state of unknown element. So suppose I have given to you to find out the oxidation state of manganese, then you will say that let's say the oxidation state of manganese is X, right? The oxidation state of potassium +1, here X, and here -8 equal to 0. So by calculating we are getting the oxidation state of manganese is +7. We will apply this rule in many cases to find out the oxidation state in my later video, right? Well, rule 4. Well, I will well, this is a sulfate radical, right? So in sulfate radical there is -2 charge on it. So how this charge is coming, right? You know that for this you have to the oxidation state of sulfur is +6 and the oxidation state of 4 oxygen is -8, equal to -2, right? So if you if you if you add +6 and -8, then you will get -2, and this -2 is going over sulfate radical, right? So and in case of chromaton, uh, we see that there is -2 charge over it. So how this is coming? You know that the chromium has +6 oxidation state. So there is 2 atom of chromium. So we have to multiply +6 by 2, and then we have to take the number of atom of oxygen, then the oxidation state. So if you add this number, then you will get 2, right? So here, and this 2 is going over 2. So however, let's read the rules here. Okay, in case of polyatomic ions, right, the algebraic summation of oxidation state of all atoms is equal to charge on that particular ion, is equal to charge of that particular ion. So this rule will be helpful to find out the oxidation state of unknown element in a compound. We will apply this rule in near future. Well, now we are going to learn the rule 5, right? What is that? You know that the oxidation state of hydrogen is +1, right? When hydrogen is going to make compound with non-metal like carbon, nitrogen, hydrogen, nitrogen, oxygen, and chlorine, right? The oxidation number of hydrogen is +1 when it is combined with a non-metal, as in methane, ammonia, water, and HCl. In all these compounds, the oxidation state of hydrogen is +1, right? Well, rule 6. Now I am going to explain the rule 6. What does this mean? Okay. In rule 6, we see that the oxidation state of hydrogen is -1, right? The oxidation number of hydrogen is -1 when it is combined with a metal like lithium, sodium, calcium, lithium, right? So in all these compounds, the oxidation state of hydrogen is -1. That is, with metal, hydrogen will have -1 oxidation state, and with non-metal, hydrogen will have +1 +1 oxidation state. This is the trick. Well, now I am going to reveal the rule number 7 for finding the oxidation state of an unknown element in a compound. So let's get started. The element in group 1A, right, shows +1 oxidation state usually, like sodium, potassium, lithium, etc. Rule 8. The elements in group 2A shows +2 oxidation state, like calcium, magnesium, right? Okay. Rule number 9. Usually oxygen shows -2 oxidation state. Like in water, the oxidation state of oxygen is -2, but in peroxide, like hydrogen peroxide, the oxidation state of oxygen is -1. In ferrous oxide, in fluorine oxide, the oxidation state of oxygen is +1, right? In potassium oxide, the oxidation state in potassium oxide, right? In the oxidation state of oxygen is -1/2, right? So you have to memorize this, right? Otherwise, you may fall in trouble. Well, we have another rule. I hope we, well, thank you for viewing this video. Be well. Here we have another rule, and in this rule we see that the elements in group 7A shows -1 oxidation state, like chlorine, fluorine, bromine, iodine. Thank you for viewing this video. Be well.